Welcome back to the deep dive. Today, we're jumping straight into a debate you hear everywhere in AI. LLM versus SLM. Large language models, small language models. It feels like everyone's focused on, size, power, parameters, billions, trillions. But here's the question we're tackling today. Is that even the right question? Focusing on size. Our guide for this is a really interesting lecture note. It's titled LLM versus SLM, Are We Asking the Right Question? It's by Jae-Woo Choi, who's an associate professor at George Washington University and also principal investigator of the CAFA initiative, that's SCAP. So our mission is to unpack this idea that maybe, just maybe, model size isn't the be-all and end-all, and figure out what really leads to reliable, smart AI that actually works for you, the listener, trying to get up to speed fast.
Exactly. I mean, there's so much buzz around AI agents, which is great, but
Yeah.
this laser focus on just the scale of the model, it might be, well, a distraction. This lecture note suggests there's a more fundamental way forward, something beyond just bigger or smaller models. We're going to dig into a concept called Ontology Model-Centered Generation, OMG for short.
OMG. Okay, that definitely gets your attention. Ontology Model-Centered Generation. So you're saying this is different. How is it such a potential shift?
Well, what's really revolutionary, potentially, is that it helps us move past the built-in limits of language models, whether they're big or small. It adds a kind of structural backbone. The idea is it makes AI smarter, sure, but maybe more importantly, much more reliable. And that's huge for, well, so many real-world uses where you just can't afford mistakes.
Okay, let's push on that then. A common assumption. Do all AI agents really need a massive LLM? It feels like the go-to answer these days. But this source, it actually calls the type of model LLM, SLM, maybe something new down the line, a secondary issue. That sounds pretty bold.
It is bold, yeah. But it comes from looking at what these models are, fundamentally. Any language model, big or small, is basically a probability machine. They're great at spotting patterns, predicting the next word.
Yeah.
But that's also why you get things like hallucination in LLMs. They can state something completely wrong, or just make stuff up with total confidence because they don't know it's wrong. They're just generating likely sequences.
Right, the prediction engine. And that brings us to what the source calls the dual dilemma. Okay, so on one side, LLMs. The analogy used is pretty striking. Using an LLM for most things is like using a nuclear reactor to power a wristwatch. I mean, yeah, it's powerful, but way overkill, right? Think of the GPU costs, massive. The carbon footprint, huge. And then there's that unpredictable creativity. Sometimes good, but in business, could be a disaster. Imagine getting wrong legal advice from an AI or financial report based on, well, nothing. That's not just an error, that's a crisis.
Exactly, a huge risk.
Okay, so that's one side. Then you've got SLMs on the other side of the dilemma. They've got pros, right? Fast, cheap, easy to specialize. But the source points out their big downsides, too. Very narrow knowledge. Not much complex reasoning. Ask them something just a little bit outside their training data, and poof, you might get nonsense or it just stops working, which doesn't exactly inspire confidence for anything complex or dynamic. So LLMs risk hallucinating, SLMs risk hitting a wall. What's the link?
You've nailed it. That's the core problem identified here. It's not really the size. It's more fundamental. It's the absence of structure. Both LLMs and SLMs sort of floating free without a strong framework run into these issues because of their probabilistic nature. Unreliable creativity or just severe limits. The way to solve this, to get past both the LLM instability and the SLM narrowness, is to build in what the source calls an ontology. And this ontology isn't just more data. It's presented as the very backbone of knowledge for the AI, giving it that structure it needs.
Ah, okay. So if the problem is no structure, the solution is deliberately adding structure. Makes sense. And that's where OMG, Ontology Model-Centered Generation, comes in. I like the analogy they use, the building blueprint. Like the blueprint is the ontology, right? It tells you where everything goes. The bricks and materials, that's like the language models, knowledge and processing. You need the blueprint to build a solid building, not just a pile of bricks. So OMG is the blueprint for the AI agent.
Precisely. OMG changes the game for how the AI agent works. It's not just driven by a huge blob of data anymore. Instead, it's built around this ontology model. This model carefully maps out the knowledge, the relationships between things, the rules for a specific area. It's not just feeding it data. It's giving it structural intelligence, as the source calls it. So the AI understands how things connect and why it takes certain steps.
And the really interesting part here is within this OMG structure, that whole LM versus SLM argument we started with, it looks completely different. It's not about which model is best overall. It becomes which model is the right tool for this part of the job within this structure.
Exactly. It shifts the focus from just raw power to, well, intelligent application of that power.
Okay, let's get into the benefits then. The source lays out 5 key ways OMG changes AI. How does it tackle those problems we discussed? First up, intelligence from the ontology, execution by the language model. How does having an ontology let even smaller models be effective?
Yeah, it's quite neat, actually. The ontology defines everything up front. The context, the steps to take, the information needed for a task. So the language model, it can just focus on what it's best at being: a linguistic interface, processing info, generating natural language, but within that strict structure. It doesn't have to do the heavy lifting of reasoning on its own.
Yeah.
Make a medical diagnosis support agent, for example. The ontology maps out diseases, symptoms, tests, treatments, how they all relate. So the agent asks the right questions, interprets results correctly, draws logical conclusions based on the ontology. And even a smaller SLM, guided by that deep structure, can be incredibly accurate and stable, way beyond what it could do just probabilistically.
That's really interesting. So the ontology is like the domain expert, and the LM is the skilled communicator, translating that expertise. It's not just a tweak. It feels like a different way to build trust, moving from more data to more certainty because of the structure.
That's a good way to put it.
Okay, but practically speaking, resources, cost, efficiency, how does OMG help manage all that?
Right, the practical side. This is where OMG really helps by creating what's called an intelligent routing environment. Basically, the system looks at the task and picks the best model or a combination of models for that specific task dynamically. So if you ask something simple, like "where's my order?", a tiny specialized SLM can handle that. It just calls a specific API defined in the ontology. Super fast, super cheap. But then if you ask something complex, like compare these 2 cameras for sports photography based on specs and budget, then the system can say, okay, for this we need more power, and bring in an LLM to generate that comparison. But crucially, even the LLM operates within a camera performance framework defined by the ontology. It keeps the element's power focused and relevant. This creates a heterogeneous system, mixing and matching models, maximizes efficiency, cost, speed, energy. You're not always firing up the reactor for the wristwatch.
Yeah, that makes sense. Using the right tool for the right job, guided by the overall plan. Very efficient. Now, let's talk reliability. Critical stuff, right? Healthcare, finance, autonomous driving. You need perfect alignment, perfect control. How does OMG deliver that, minimizing those creative mistakes?
This is absolutely key. The standard way, RLHF reinforcement, learning from human feedback, it shapes AI behavior through rewards. Do more of this, less of that.
Yeah.
But it doesn't give the AI a fundamental understanding of why. It's more like surface-level training. OMG is different. It structurally aligns the AI. The rules, the logic, they're baked right into the ontology explicitly. The source argues this is the most reliable path to getting verifiably accurate actions. It forces the AI to stick to the script, the protocols. No room for those creative mistakes. And that kind of built-in control, it's non-negotiable for fields where errors have serious consequences.
Yeah.
Finance, law, self-driving cars. Absolutely essential.
Verifiably accurate, that's a powerful phrase. Shifting from probably right to provably right within its domain. Big difference.
Huge difference.
Okay, what about growth? How do these systems scale or adapt? Adding new features, new knowledge. Usually that means massive retraining, right? Expensive, risky.
Yeah, that's a major pain point with monolithic models. But OMG offers a way around that. The source uses metaphors like a cooperating team of specialists or Lego blocks. Because everything revolves around that clear, modular ontology, you can plug in different spatialized SLMs or tools pretty easily. Like Lego. Say you're running an e-commerce site and want to add a new return processing function. With OMG, you don't retrain your giant core model. You just define the rules and steps for returns in the ontology itself. Then you connect a dedicated module, maybe a small SLM, maybe an existing API, just for that task. It drastically cuts down development time and risk compared to messing with a huge, complex model. It's built for modularity and scaling.
Wow, okay. That sounds much more manageable, like building with the components instead of carving from a single block. And finally, how do these systems actually learn? Can they improve over time in a meaningful way beyond just getting better at, generating text?
Yes, and this is where it gets really interesting for long-term value. The data you gather from user interactions, it does more than just fine-tune the language model's fluency. It actually feeds back into refining the ontology itself. Imagine an agent keeps having to ask users for clarification about a certain term or process. The system can flag that. It can recognize, hey, this concept seems fuzzy or incomplete in our core ontology. And it could even suggest ways to revise or add detail to the ontology. So the AI's intelligence grows structurally. The core knowledge framework itself evolves. It's not just tweaking performance, it's making the blueprint smarter, more complete over time. True adaptive learning.
Okay, that paints a really compelling picture. It feels like we've really explored a different way of thinking about AI. So, pulling it all together, what's the main takeaway from the source?
The main message, I think, is pretty clear. Look, LLMs are amazing tools. They'll still be vital for creativity, for tapping into vast general knowledge, for complex pattern finding, no doubt. But the source argues that the real competitive edge, especially as AI agents become more common, won't just be about who has the biggest LLM. It'll be about who has built the most sophisticated, practical ontology model optimized for their specific industry.
So, the ontology itself, that becomes the key asset, the real technological moat, as they say.
That's exactly the idea. Language models will keep changing, getting better, faster, smaller maybe. That technology evolves rapidly. But a well-built ontology, that deep structured knowledge for a specific domain, that's model independent. It's a core asset that lasts. It's not something you can just replicate easily by throwing more compute or data at the problem next year. It takes deep domain expertise to build.
Right. So, what does this mean for, say, strategy, for companies or even countries trying to build strong AI capabilities?
Yeah, the source touches on that with this idea of a sovereign AI strategy, which is quite interesting. Instead of just trying to keep up with the giant LLMs from, the huge tech companies or only focusing on small niche SLMs, a potentially smarter path is to invest heavily in building world-class ontology models for your key industries. Manufacturing maybe, or healthcare, finance, law. Then you build an OMG-based agent ecosystem around that core ontology. And that ecosystem can intelligently use the best available LLMs and SLMs as needed. They become tools plugged into your unique knowledge structure. Think about an AI agent built on a super deep ontology of semiconductor manufacturing. It could predict yields, manage supply chains, optimize processes with incredible precision. That gives you a powerful competitive advantage that's really hard for others to copy, even if they have bigger general models. This source presents this as maybe the surest path to break free from just depending on others' base models and achieve, well, true AI sovereignty.
That's a really powerful vision, building foundational knowledge structures as the core strategy. So for you, our listener, wrapping this up, the big takeaway today, when we talk about truly smart, reliable AI, maybe it's less about the size of the hammer and much more about the quality, the precision, the depth of the blueprint. The future isn't just more data, it's knowledge, brilliantly structured.
Exactly. And maybe a final thought to leave you with, something to mull over. Think beyond just AI for a second. How could building clearer ontologies, these structured ways of understanding things, how could that apply in your own life or work? Are there complex areas, maybe in your job, a project, even a hobby, where defining the key concepts, relationships, and rules more clearly, building your own mental blueprint, could make a real difference? What domains could benefit from that kind of structured thinking?
That's a great point. Shifting from just gathering more information to building more structure and how we understand things, it definitely changes how you think about AI's future and maybe even your own approach to knowledge. Lots to think about there. We'll see you next time on The Deep Dive.